one of the world's most productive ecosystems and vital in the protection of coastal environments, mangrove forests are primary producers and play a crucial role in nature. Tropical mangroves in particular are studied for their productivity worldwide, as global distribution patterns show tropical dominance of these forests in relation to the world's oceans. Mangroves have also been at the forefront in recent years of study relating to the world's current carbon issues. These studies have shown that these plants have the ability to capture and store carbon, removing it from our atmosphere and allocating it below ground to be held in pools of soil and roots. This sequestration may also be vital in providing carbon sources for invertebrates along intertidal mangrove habitats. However, different species of mangroves have shown different levels of ability in this area of carbon sequestration, which also changes according to their biogeographic properties and their environmental dispersal. For example, it was shown in a study conducted in southeast Queensland, Australia, that the composition of these plant species can influence their sequestering abilities along the coastline. Oligotrophic salt marsh plants in the east had higher rates of carbon sequestration than those further west, due to their location and biological structure. Unfortunately, the distribution and abundance of mangrove forests globally has declined over recent years. Mangroves face multiple threats, which vary according to their geographic location and distribution. One large threat is urbanisation along coastal zones, which results in direct habitat loss, as well as indirect effects such as pollution and general environmental degradation. In China, for example, between the years of 1973 and 2000, more than 60% of their mangrove forests were lost, with only about a 12% recovery rate from 2000 to 2015. Mangroves have been used all over the world, both traditionally and commercially, as sources of timber, food, and fuel, as well as for charcoal and product creations for tourism. They're threatened by deforestation, overexploitation for industrial use, and aquaculture. In areas where coastal populations are rapidly increasing, such as in Vietnam, mangrove forests have been destroyed along the Mekong River Delta for aquaculture purposes and replaced with shrimp farms. The growth of shrimp aquaculture has changed the landscape of coastal ecosystems all over the world. In Sri Lanka, over almost 20 years, mangrove habitats declined by approximately 34% due to the installation of shrimp farms. The blue carbon stored in these sinks is potentially lost due to the land use changes and released into the atmosphere, becoming a source of greenhouse gas. Not only are the current carbon sinks being destroyed and released, but additional greenhouse gases are being emitted during land transformations. A study conducted in Saudi Arabia this year compared the stored organic carbon levels in mangroves against those of the implemented shrimp farms. It found that the mangrove forests had over 140% higher capacity to store carbon than within the aquaculture. The sophisticated ground structure of mangroves can promote the trapping of sediments, and the sedimentary layers within these forests have greater organic content than those of shrimp farms, which means they have a higher potential to act as a carbon sink. Some studies have already been conducted into the potential for restoration of mangrove forests. Aquaculture ponds have been found abandoned after they're no longer viable for production, and these have the potential to be restored, as it has been noted that mangroves have self-repair abilities to successfully repopulate. However, shrimp farms have now become an important source of income for people all over the world, specifically in Asia and Latin America, where the conversion of farms back to forests would see a loss of employment for some populations. In order to sustain employment and continue providing an income source for those populations who rely on shrimp farming, some ideas have been put forward. Mangrove shrimp integrated farming is considered a potential solution to both shrimp cultivation and blue carbon emissions. Not only will it prevent extensive global mangrove loss and therefore support the fight against climate change in the reduction of carbon emissions, it is also a flexible compromise for farmers, ensuring better returns for the communities with economic analyses and benefit-cost ratios showing profitable earnings. This practice is now commonly known as silvo-aquaculture or silvo-fisheries, and is essentially referring to an environmentally friendly form of aquaculture, as opposed to the past unsustainable practices. It will include utilising the favourable biophysical conditions of these mangrove forests, instead of destroying them and completely altering the landscape. The use of carbon credits as compensation for sustainable forestry practices may also be a potential incentive for environmentally friendly work. Carbon credits and trading systems are considered the future for carbon sequestration practices as a reward for the offset of their emissions, and another important stage in international climate policies. After studies into these integrated farm systems began, it was also found that mud crab fisheries may provide even higher social and economic benefits for local coastal communities, as the physical condition of the mangroves are better suited to crab cultivation. It is also well known that aquaculture requires a considerable amount of inorganic nutrients for successful farming. However, the ever-amazing mangroves have also been shown to potentially remove a substantial amount of these from the effluents of this practice, including ammonium, phosphate, and nitrates. Mangrove forests are an essential and irreplaceable ecosystem, naturally fighting against greenhouse gases and global warming. They capture and store a considerable amount of blue carbon, which would otherwise be released into our atmosphere, adding to all of our other climate change concerns. However, these implemented practices of silvofisheries and carbon credits will now aid in ensuring the protected future of these forests, as well as a continued source of income for local farmers and communities all around the world.